So chapter 5 of MYP4 unit 2 is inverse functions. In the last chapter we talked about breaking functions down with flowcharts and then going backwards through those flowcharts, doing reverse things to get a rule that would work in reverse. And such a rule is called an inverse function. Okay, so we can say that f of x equals 3x plus 2, and there's a little minus 1 there as notation to denote inverse function, and f minus 1 of x is x minus 2 over 3. That's supposed to be an x in case you're in doubt, so x minus 2 over 3. So they're inverse functions, each undoes the effect of the other. So for example, when x equals 112, if we calculate f of x, and I suggest you do that now, find out what f of x comes out to be, and then take that f of x and put it in f minus 1 of x, and you should get back to 112. So pause the video, try that, and then we'll reveal the answer. Okay, so I hope you paused the video. Here it comes. So if you put 112 into f of x, you get 3x plus 2, which is 3 times 112 plus 2, which is 336 plus 2, which is 338. And then if you take that 338 and put it into the inverse function, so x minus 2 over 3, so you get 338 minus 2 divided by 3, which takes you back to 112. So we did an exercise in class. Here are some functions, 4 questions. You have to represent them as flowcharts and then find their inverse functions. So what function will undo the effect of 2x minus 1? What function will undo the effect of a third x plus 8? What function will undo the effect of 6 minus x? And what function will undo the effect of 1 over x? These last two, there's something tricky about them which you need to give special thought to. So pause the video and just review those and see how you get on. Okay, so I hope you paused the video and had a go at those. Here come the answers. So 2x minus 1, if I start with x, have a box that says times 2, that gives me the 2x. Then I do minus 1, that gives me 2x minus 1. So for example, 3.1 in would give you 6.2, and then minus 1 would give you 5.2. So to get the inverse function, I'm going back the other way through the flowchart and trying to do opposite things. So starting with x going in the right side and working to the left. The opposite of minus 1 would be add 1. So x in add 1 would give you x plus 1. And then the opposite of times 2 would be divide by 2. So x plus 1 into a box that says divide by 2 would give you x plus 1 over 2. So the inverse function of that is x plus 1 over 2. So using the notation that's been given in the question, if f of x is 2x minus 1, then f minus 1 of x, the inverse function, is x plus 1 over 2. Those two functions undo the effect of each other. So if you were to put the 5.2 into this, you'd end up back at the 3.1 you started with. So just to recap on that idea, we say that f minus 1 of x equals x plus 1 over 2 is the inverse of f of x equals 2x minus 1, and that works the other way around as well. 2x minus 1 is the inverse of x plus 1 over 2. Each of those functions undoes the effect of the other one. So here's question 2. So f of x equals a third x plus 8. So if we started off with x going in, and then I've tried to do it with a specific number just so that I can check it works and check the inverse works when I do it. So if I start with x in, then I'm dividing it by 3 to get a third of x, and then I'm adding 8 to get a third of x plus 8. And then if I try and do that the other way and do the opposite things, so the opposite of add 8 is subtract 8, and the opposite of divide by 3 is times 3 or multiply by 3. So if I start with x in the other end, the right hand side, and try and do the opposite things, I'm doing x in, subtract 8 gives me x minus 8, and then multiply all of that by 3 to get 3 times x minus 8. So if f of x is a third x plus 8, then the inverse function, f minus 1 of x, is 3 brackets x minus 8. Both of those functions will undo the effect of the other one. And you can test that by putting 126 in and then seeing that you get 50 out, and then putting 50 in the other one and seeing that you get back to 126. It doesn't have to be 126, I just randomly thought of that number. It should work for any number. Right, question 3 was the tricky one that you had to think of, because the opposite of subtracting something from a number is subtracting it from the number. For example, 100 minus 17 is 83, and 100 minus 83 is 17. Subtracting from the number is its own inverse. So if I start with x in, subtract from 6 gives you 6 minus x. So for example, 1.7 in will give you 4.3 out, because you do 6 minus 1.7. But then the reverse of subtract from 6 is still subtract from 6. So x in the other side, subtract from 6 gives you 6 minus x again. And using actual numbers, 6 minus 4.3 is 1.7. So that's a tricky one there. Subtract from something is a self-inverse function. So in fact, the inverse of 6 minus x is 6 minus x. It undoes the effect of itself. And question 4 is another tricky one, because dividing into 1 divided by x, so you're dividing x into 1, is another self-inverse function. So for example, 1 divided by 5 is 0.2, but then 1 divided by 0.2 gets you back to 5. So 1 over x is the inverse of 1 over x, and generally dividing into a number is a self-inverse function. So here's some super challenging ones, because they've got the x's in funny places and there's lots of steps to it, and parts of those steps involve self-inverse things. So question 5, if the function of x, f of x, is 18 over 3x minus 5, what is that when x is 12? What would the inverse function be? So you're going to have to break that down with flowcharts. And then you're going to try the inverse function when x equals minus 4.5. And then question 6 is trickier still, because it's got more bits to it. So if f of x is 8 over 2 minus 3x, you've got to work out the inverse function of that, and you're going to do that by breaking it down into flowcharts, going the other way back down the flowchart, and remembering what type of function is the inverse of another type of function, including self-inverse things. So that's quite complicated. Pause the screen, have a go at that, and don't worry, it's tricky, but I will go through it step by step. So I hope you paused the screen, and here we go. So 18 over 3x minus 5. If I want to break that down into a flowchart, I might start with x, multiply it by 3 to get 3x, and then to get 18 over 3x, I'm going to have to take the 3x and divide it into 18. So the box is going to say divide into 18 to get 18 over 3x. And then finally subtract 5 to get 18 over 3x minus 5. So I've broken the process that you need to do to get 18 over 3x minus 5 into steps. And then the next thing I'm going to do is think about what the reverse steps would be going the other way to get back to the same number. So the opposite of subtract 5 would be to add 5. The opposite of divide into 18 would be to divide into 18, because dividing into something is a self-inverse function. And then the opposite of times 3 is divide by 3. So if I take x and put it through those steps, I get x, add 5 is x plus 5. Divide that into 18, I get 18 over x plus 5. And then divide all of that by 3, I get 6 over x plus 5, because 18 divided by 3 is 6. So that gets us to 6 over x plus 5. So the inverse function of 18 over 3x minus 5 is 6 over x plus 5. Each of those functions undoes the effect of the other. And you can check that by putting a random number into that and seeing what you get out, and then putting that result into 6 over x plus 5 and seeing that you get back to the original number. And then here, in fact, I'm doing that. So I started with, let's say x is 12. So 18 over 3x minus 5 would be 18 over 3 times 12 minus 5, which comes out to be minus 4.5. So I ought to be able to put minus 4.5 into the inverse function and get back to the 12 I started with. So I tried that. When x is minus 4.5, 6 over x plus 5 would be 6 over minus 4.5 plus 5, which would be 6 over a half, which will be 12 again. So it does get us back to the number we started with, so they are inverse functions. Then the last one of those, so starting with f of x equals 8 over 2 minus 3x. So I'm saying to myself, what do I need to do with x step by step to get 8 over 2 minus 3x? So starting with times 3, if I put x in and times 3, I get the 3x. And then if I subtract that from 2, I get 2 minus 3x. And then if I divide that into 8, I get 8 over 2 minus 3x. And then to get the inverse function, I just went the other way down the diagram and I thought, what are the reverse steps of all of those steps I just did? So the opposite of divide into 8 is still divide into 8, because dividing into something is a self-inverse function. The opposite of subtract from 2 is still subtract from 2, because subtracting from something is a self-inverse function. And then the opposite of times 3 is divide by 3. So if I put x into all of those steps, going the other way down the diagram, starting with x, divide into 8, I get 8 over x. Subtracting from 2 makes it 2 minus 8 over x. And then dividing all of that by 3, so I've just got all of that I've stuck in a bracket, and then a third of that. So if the original function f of x is 8 over 2 minus 3x, then the inverse function f dash of x is a third of, brackets, 2 minus 8 over x.